So welcome to the first discussion about reactive streams. We're going to do a real quick recap of reactive programming principles. This is very similar to our discussion we did when we talked about completable futures, but there's just a few things that are a little different in this discussion. So first and foremost, we're going to talk about what reactive programming principles are. Hopefully this will be familiar to you. Responsive, resilient, elastic, and message-driven. Those are the four key principles. And we'll again reiterate what reactive programming is. It's an asynchronous programming paradigm, which means that things run in the background, decoupled from the invocation often. And it essentially takes streams of data and processes them, transforms them, filters them, and so on, and also is responsible for propagating changes from publishers to various subscribers. And in the context of reactive streams that we'll be talking about here, basically the way it works is it composes together asynchronous and event-based sequences or observables or fluxes, as we'll see, using a whole range of non-blocking operators that can be mapped to various threads. And you'll see that one of the cool things about reactive streams programming frameworks like RxJava and Project Reactor is they give you very, very fine-grained control over where your computations actually run. Reactive programming is particularly useful to support certain types of scenarios. One type is processing user events, so things like mouse movements, mouse clicks, touch events, GPS location signals coming in from sensors, and so on and so forth. And you'll see that there's actually something called Rx Android, which is an Rx version of Java that runs on the Android platform. And that particular implementation gives you lots of cool capabilities to work with GUI-related events. This class doesn't really focus a lot on GUIs, but if you were to be using Rx Android or Rx Java in the context of Android, then undoubtedly you could use all the GUI-based processing. This class, as you no doubt have noticed, is a lot more focused on responding to and processing latency-bound I/O events, or I/O events, as the case may be in our context where we're downloading these images. And that's really the focal point for most of the discussions here. Not that the features discussed here are not relevant, it's just that we're going to be using more networking and file I/O and concurrency and so on as the driving motivators for what we'll be talking about in the context of reactive streams. So imagine, for example, as shown here, that you've got data feeds coming from somewhere like Twitter messages, and you want to figure out, which candidate is going to win the election, or what the sentiment is about famous reality TV celebrities like the Kardashians and Kanye West or whatnot. You could take that Twitter feed or those Twitter feeds and then run them through a series of event transformers, which would exert back pressure if the data was coming in too fast, which would filter out things that weren't of interest to you, would be able to do some kind of sentiment analysis to say whether people are happy, unhappy, dissatisfied, et cetera, et cetera. And then you could propagate the sentiments that you had analyzed to various observers that would do something in response. They could go vote, or they could, go and watch Keeping Up with the Kardashians, or whatever it is that you want them to be able to do based on this. If you take a look at the link at the bottom of the page, it gives some nice video that talks more about this particular kind of use case. As we've seen before, there are four key principles involved with reactive programming. Responsive just means that you get the data quickly and with a consistent response time. So you don't want to have long lags or long latency or inconsistent latency with respect to getting the results that are coming in, that are streaming to you from some device or some feed or whatnot. So you want to be able to have things be responsive, get the information quickly. Resilient, as we've talked about before, just means that if something goes wrong, the whole system doesn't come crashing down, but instead the system should continue to run, or the application should continue to run, and just the particular operation that failed may need to be retried or may need to be cleaned up or whatnot. We also want systems to be elastic, and what that really means is that you can make them run faster by throwing more resources at the problem, so more cores, for example. And even as the workload goes up, if you play your cards right, you should be able to auto-scale the performance. Now, in the context of reactive streams, we'll be talking about, we're really limiting ourselves to auto-scaling on a on cores in a multi-core processor if you're talking about the packages that come out of the box. However, you can always integrate these things with other more microservice or cluster-based approaches in order to get greater scalability that works across a cluster or a network of computing devices. That is not what we're going to focus on, but that's also something that's available within the paradigm and the set of tools that we'll be talking about. A good example would be something called WebFlux, which you can use to write microservices that use reactive techniques. And then the fourth and final topic here, which is, again, just a real quick recap, is this whole concept of message-driven implementations and designs, which is really an implementation detail relative to the other principles. And the whole idea here is that you want to keep things loosely coupled. You want to isolate different capabilities within different components so they don't have to be tightly coupled. You want to have location transparency so you can rearrange what cores or what computers things actually run on. So these are the four main principles. These are, as you can see, the same principles we used when we motivated completable futures. And one of the key things we're going to do here by the end of today is talk about how completable futures compares and contrasts with reactive streams. So we'll get to that in just a second. But keep in mind that they're all techniques for being able to address reactive programming and trying to fit in with the key principles in the reactive manifesto that we just covered.